Welcome to our video on multiple motion. We've got here written an example of multiple motion. Take a minute and put it into your notes. The question says, a sprinter is able to complete the 100-meter dash in 12.4 seconds. Afterwards, it takes her 22 meters in order to slow down completely. What was her velocity when she crossed the finish line, and what was her deceleration after the race? So the easiest way to visualize this as a multiple motion graph is to draw them out with our graphs first. So we can see in our first motion, the person's going to be racing as fast as they can, which means they're going to be accelerating. So the first part of the graph is going to be a curve upwards like this. Afterwards, when they've crossed the finish line, which we're going to represent by the yellow line, they're going to slow down. So it's going to be a curve yet again in the positive direction. So if we were to draw this as a velocity time graph, we would see that it would be a straight line upwards, and then afterwards it would be a straight line downwards. So this is supposed to be a straight line. From here, when it comes to acceleration, our acceleration would be in the positive first, and then would be in the negative afterwards because you're slowing down. So what you can really see is you can see this is our first motion here during the race, and our second motion here after the race. So when we're writing out our information and what we're given, we need to make sure we talk about it either being during the race or after the race. We need to separate them entirely. So for example, this 100-meter dash in 12.4 seconds, this particular case, this displacement is 100 meters during the race. So we're going to arbitrarily say that's movement to the right. And we're going to say the time here is 12.4 seconds. This has nothing to do with going on in the second motion. We know in the second motion, we're traveling an additional 22 meters. Now what else? This is all the information that we're stated. This is our explicit information. Now we need to think about the implicit information. What we're told, but isn't necessarily written down clearly for us. Well, we know if it's a race, that the racer, she's probably starting by not moving. So we'll say our V1 is equal to 0. We don't know what the final velocity, or V2, is going to be. But we do know enough from this information to know that if we've got displacement, time, V1 and V2, we should be able to use one of the equations to figure it out. So I'll just scroll down a little bit. And we can see the equation that fits these four is that displacement is equal to V1 plus V2 over 2 times time. So if we plug that information in, so 100 is equal to 0 plus V2 over 2 times 12.4. We can rearrange and find that our velocity ends up being 16.1 meters per second, and we need to include the direction of being to the right. Now this is what makes a multiple motion question unique. We can see now here from our graphs that our V2, or our final velocity right here, our V2, is going to be 16.1. But what that also means is that the second velocity in the first part of the graph is the same as the V1 of the second part of the graph. So our V2 right here is equal to our V1 over here. So we now can take that information and say in the second part of our graph, when we're moving, that our initial speed is 16.1 meters per second. We had to solve the first part of this question if we wanted to be able to get the answer for the second part. So now what else do we know? We know that our V2 is going to be equal to 0 because eventually you're going to stop running. So from here what the question is asking us, what is our acceleration? So we can look at our four pieces of information that are given, and we can say that the formula we need is 2AD is equal to V2 squared minus V1 squared. So from here what we can do is we can plug in our numbers. So 2 times A times 22 is equal to 0 squared minus 16.1 squared. So a times 44 is equal to, now what's important to realize is that this negative sign right here is not included in the square, so our number will end up being negative. Which means our negative acceleration here is going to be equal to negative 5.89 meters per second squared to the right. And that makes sense. We would expect it to slow down as we go.